Hello, everyone. Welcome back to another episode of Solidity Fridays. Super keen to have you all here. I'm joined with Myles, who is a Solidity developer from Linum Labs, and this is his first Solidity Fridays. And yeah, welcome, Myles.
Hey, Gareth. Nice to be here. Thanks for having me on the show. I look
Yeah,
forward to getting into it.
it's been a long time. We've been wanting you on for a while now. Myles is a very good Solidity dev, and hopefully he can help me walk through Cask protocol today.
Yeah,
Um,
automation
but
on the
yeah,
block. Mm.
exactly. Automation. So last week we covered another protocol that did streaming payments, but we realized quite quickly that it was more of um, it wasn't really for like monthly debit orders or things like that. It was more of a way of just splitting up a payment over multiple different um, kind of instances, and then when you want to get paid your $2,000, whatever it may be, you just can come onto the platform and claim it. But it seems like Cask is allowing kind of a subscription model where people can come on and pay a subscription to, I don't know, Netflix, Spotify, whatever it may be, but using crypto. So let's see. Hopefully that's exactly what it is. But I'm sure nonetheless we'll learn. So yeah, save time, money, and effort with automation. So they obviously their big focus is to automate different flows. So they've got subscriptions, DCAs, which are auto buying kind of different cryptos. They've got Chainlink top ups, so keep your Chainlink VRF automation balances funded automatically with stablecoins. Oh, that's cool. So that's obviously um, to call Chainlink and stuff like that, you need funds. So maybe it automates that. And then peer-to-peer payments, so sending funds automatically. So yeah, so they've got four main use cases. So before we jump into the code, let's jump into more info on each of these. I
Yeah,
hope my Wi-Fi plays part.
I'm really keen to see these subscriptions. I mean, being able to pay my Netflix subscription by crypto automatically, that's a dream.
That'd be crazy. We just need Netflix to accept Bitcoin first. Although I did see that they accept stable coins. So they only deal with stable coins, which makes sense because like Netflix isn't going to want to accept Bitcoin today and then it's worth half the price tomorrow
Yeah,
or double the price, I suppose. So yeah, I guess it'll all be stable coins. I don't know if that's limited to like specific coins or if it's basically any coin that's stable. But yeah, so it accepts stablecoin payments, contributions, or donations. And if you're a subscriber, you provide an NFT as proof of subscription. Okay, so they're using NFT as a way of um, showing that you have a subscription, and then that's used for access control and gating content. Okay, cool. So um, this just looks like a screenshot. We don't have to go into that. Um, So it features functionality from a subscription management platform with NFTs. So there's NFT token gates to make sure that like you can access. Um, you can set whether or not your NFT subscriptions are transferable. So I guess you could transfer to someone.
mm.
Um, create scarcity by limiting the number of subscriptions. Okay. So it seems like you could also use this to create a subscription model, not just to subscribe to something.
Yeah,
Uh,
that's what it seems. It seems like it's your clients come on and create their own subscription, and
mm.
then the next client comes on and makes a totally different one for their needs. It's like per use case.
Netflix would actually come on here and then
Mm.
create their subscriptions to that. Um, cool, but they've got a whole bunch of things: discount codes, free trials, plan management, interval configuration, and payment retrial. So I'm not going to go through this too much, but I see there's no gas fees for recurring transactions, which is a big plus. Um, I'm not exactly sure how they'll do that, but that'll be interesting to see in the code. Um, yeah, so there's subscriptions, which we'll see more of in the code. There's dollar cost average buying. So you can automatically buy your favorite crypto tokens on a schedule. So you can say that every month you want to put $5,000 into a specific crypto, and it will buy every month for you. Um, so that's also really cool. But what's nice is that it also have range bars, so you can also kind of only buy if it's in a certain range. So you don't want to buy if it's gone super high. So you can almost make sure that if it's not, too hard, then you only buy. They also use the cost average, which is quite cool as well. So you don't have to worry too much about fluctuations. And there's a lot of flexibility around it. So I'm also quite keen to see that. So you have a Cask wallet, and then you obviously all your payments come out of the Cask wallet. Or you can set an allowance to spend stable coins from your personal wallet to your flows. So then basically Cask will have permission to spend from your wallet, which is also cool. We spoke recently in an episode about Permit 2 from Uniswap, which kind of stops the allowance thing. So maybe one day we'll see a platform like that integrate with Permit 2. That'll be quite cool. Cool. So if you want to start an auto bar, let's see this. Just kind of want to see the flow of how it goes before we jump straight into the code. Let's connect a wallet.
Sorry, guys, for those of you not in SA, that is just my power coming back from load shedding.
Okay, cool. So that network's not supported. I don't know what network I'm actually on, but let's just go into Arbitrum. Okay, anyway, whatever you want to go onto, it obviously allows you to, there we go, switch network. And then you can accept payments, you can buy, you can top up your Chainlink balances. So there's a whole bunch of stuff you can do, which is really cool. Cool. Get into the last two things. Chainlink top-ups, I'm not going to go into. It's basically just topping up with like a link or something so that you can perform Oracle calls. And then peer-to-peer payments to send money to family, etc. So quite nice that they got like different like ways and different things you can do. I guess they probably started with like subscriptions and just expanded out, I guess. I want to see if they have any documentation online about like the platform, like the SDK. Let's see here. Okay, so this is just basically how to install Flow subscription. Okay, nothing too hectic. Cool. So we jump into the code.
Let's get into it.
Sweet. Okay, so they basically in their README just explain how to download a local Hardhat project. So they're using Hardhat. Jumping to, so this was actually updated 2 weeks ago, funny enough. So they are still busy working on it, which is crazy.
Yeah, it says they're constantly doing more new flows and trying to integrate with new things, which is awesome. It's nice to see that nice to see they're keeping up and not just letting it go idle.
Exactly. Okay, so a whole bunch of deployments for different chains. Cool. So let's dig into this. So they've got Chainlink top up. Okay, so this is that whole section. We can jump into that at some point. They've got the DCAs. So this was automatic buying. So we've got that. They've got their subscriptions. So the subscription manager, and then they've probably got a peer-to-peer.
P2P.
There we go.
Yeah.
They got their 4 sections. Yeah. Then I wonder they've got a DAO as well.
Yeah, the DAO makes decisions about which flows are coming next, and usual community voting.
Okay, so then they've got the treasury, which is cool, and then core is just the, okay. So let's maybe jump into their token and see if there's anything special they've done here. So basically, just a standard ERC20 that they've called the Cask token, and you can mint 2 at an amount. Only the owner can mint, and then if the total supply is 0, hectic. Okay, so they only mint once.
Yeah, Seems that way.
One mint, because what will happen is if the total supply goes up, you can't mint again. So that's very interesting. So they can't remint any Cask tokens. So it's a deflationary token. It's limited to
That's
a specific
interesting.
amount. Yeah, that is very interesting. I wonder how many tokens they minted at the start. But anyway, so they minted a whole bunch of tokens. So let's see how the DAO works before we get into anything. Treasury. Cool. So they've upgraded to Solidity 0.8. They use ownable interface are claimables. Obviously, got a claim function.
Yeah.
This is not too complex. Their treasury, they've basically just got a withdrawal function, which withdraws an amount of a certain asset, but only the owner can withdraw, which makes sense. So they just transfer from the treasury to a specific person. I wonder if the owner, it would be a little bit more trustworthy as a system if the owner was a Gnosis safe wallet or some sort of multi-sig wallet, so that there's not like one power controlling everything. So that would probably be a bit better if they could. I'm not sure if it is, but it would probably work a bit better or have a little bit more trust for the users of the system if they knew the money had to go through a vote or something. Then they've got an execute function and a claim. So execute takes in an address and a value and then some sort of data. And it okay, so that's sending that's if it's ETH.
Yeah, that's low level.
Yeah, so it's basically if you're wanting to transfer ETH, then you call the execute function to whoever you want to transfer to. Because obviously when you transfer ETH, it's a different way of transferring funds compared to a normal ERC20. And then they have claim, which does something, but I'm sure we'll get into that.
Yes, we have to dig into that, yeah.
Cool. They have an escrow contract. This seems like where most of the meat is. He has the claim function. So it takes a recipient in, so someone who's claiming. It's non-reentrant because there's transfer happening. So total vested of, where's that? That'll obviously return how much someone's vested, I would assume, of a recipient. And then claimable is how much you've vested minus how much you've already claimed. And then what they do is they add how much you've claimed on before they transfer. It's just a protection measure. And then they transfer how much you are able to claim to you. So that's quite cool. So you obviously can just claim extra funds that you haven't spent yet out of your wallet. But I see it's a public function. I'm surprised it's not internal because it gets called here. So this external function gets called first and calls claim with the message.sender and then creates and then calls this function. So I wonder why they didn't just make this function public and just send in message.sender. Oh, wait, I know why. Because yes, okay. Because they want the sender to be this contract. So by calling it from this function, then if they say claim message.sender, then this contract can also call this function because the message sender in this case would be this contract.
It can basically call itself.
Exactly.
That's awesome.
Because then that sends money from this contract from the escrow contract to, so it's like how much money is in the escrow contract, and then you can withdraw out of the escrow. So yeah. So they have a reward token, which I'm sure gets set here. Okay, so they send in the address of the reward token. An admin, fund admin, start after duration, initial lock supply, unallocated supply. Okay, then a whole bunch of mappings. don't want to focus too much on this because I want to kind of get into subscriptions and stuff. But
yeah, it would seem that each network or each provider has their own treasury and escrow, so they're all separate. It seems that way.
Okay. So yeah, basically you can set your admin, and you can set your fund admin. You can add tokens by transferring from message.sender to this address. So obviously the message.sender would have to have created an allowance for this contract. You can fund money into the escrow with a starting time and a duration, and recipients of that escrow money in an amount. This you can do as well, but this seems to just not have a duration. It's just obviously the amount of time. And then this one also, it just doesn't have a starting time, so it will just be from straight away. Cool. Then it's the logic, and disable can disable. Disable can disable. So you basically you can't disable. Cool. I want to get into the subscription stuff.
Yes, please.
I'm really keen to see how they've done that. So yeah, let's jump into that first.
Let's jump into subscriptions,
yeah. Cool. So there's plans. So let's maybe go to plans first. Let's just see.
Should we not check the interfaces out first?
We can do that.
Get a sense of what they're trying to do.
Okay, so we've got our car subscription plans.
Some enums.
So they have the status of the plan. So it's either enabled, disabled, or it's end of life. They have a discount type if there is a discount, or if there isn't. Then they have a discount. So you can get a discount. It has a value. It's valid after a certain date. Expires at a certain date. There's obviously a certain amount of times you can redeem it. The plan for that, the discount's on. Okay, quite cool. The type of discount and is a fixed discount, or if it's variable. There's a provider, which is, I think, I would assume, are people who started the...
Yes, the service provider.
Yeah.
People that the users pay.
Cool. So then you can set your provider profile, get a provider profile, get plan status, get plan your end of life. You can disable a plan, enable a plan, retire a plan, verify a plan. So a whole bunch of stuff you can do around plans. Let's just do this. So we've got plans, and then we go here, and we can also open plans. Cool. So it's also ownable and pausable.
Base relay recipient.
I'm not sure what base relay recipient is. Okay. Cool. So they have a subscription manager contract, which we'll get into. Yeah. So they have the address of that. They keep all their provider profiles in a mapping. They have a mapping from the provider profile to a specific plan and that plan status, as well as the plan's end of life. I'm not sure why they don't just map it to the plan, because then you can get the plan status and plan's end of life, but they obviously find that's better. Then they're mapping an address to a UN, to a byte, to a Jeepers, discount redemptions. So they're obviously mapping a provider to a plan. Okay, we'll have to see when we get there. I'm trying to figure out what they've...
Nah, we have to look at that function.
Yeah. And then they've got their subscriptions address. Some modifiers. Only the manager can do some stuff. Only subscriptions can do certain things. And they call the initialize function.
Yeah, that's because it's an upgradable contract. It's an open.
Exactly. Open Zeppelin upgradable. So that's cool. So initialize gets called first, and it calls ownable initialize, pausable initialize, and it sets the subscriptions address as address 0. Cool. They've got the version here. This is like a whole bunch of admin stuff they have to do first.
Yeah.
Get the message, or a function that gets the message.sender, and it just returns the sender. Same for data. Cool. Let's get into some of the code. Sweet. So you can set a provider profile. So you just send in the payment address and some call data, as well as the nonce. And this overrides, what is it overriding, I wonder? It creates a profile for you with the message.sender, or the sender, so whoever's setting this profile. And then it just checks that the nonce is bigger than 0, and if it is, if the profile.nonce, okay, so the nonce they sending in, if that's bigger than 0, then we require that the nonce is bigger than what they sending in. Yes, otherwise you'll have an invalid nonce. Cool. Then it sets the payment address, as well as your the data and the nonce, and then it emits an event. So there's 2 ways people can do this. So like, it's interesting that I wonder what's cheaper. So they've created a profile, a provider object first, and then created its information. Or you could actually create the profile with its information at the same time. So that's interesting that they've done it that way. I usually like to say almost like provider store, and then you just go provider. No, you go
say profile
provider profiles at message.sender equals provider, and then open brackets, and then put all the information in. So I'm not sure what's cheaper. I'll actually investigate that. Cool. So get provider profile. You just send in the address of a provider, and it'll look it up in the mapping and return it. I'm not sure where they use that, but like, it's normally you don't actually, is provider profile, it's internal, it's not public, so you can't just get it. You want to verify a plan, you can, I wonder if the NAT spec is in here. No, actually, they don't really have comments, eh?
I think it's in the interface.
This is the interface.
Oh, is this interface? Oh,
yeah.
No, that's not there. Yeah.
Yeah. So you can verify a plan. So they use a Merkle root to verify that the plan actually exists. You can get your discount redemptions, which is this is that function. So you send in the provider and the plan and the discount ID. Okay, so the discount ID is bars32, and then it returns how many times you redeemed a discount. Verifying a discount. So this function very much has to do with like discounts and setting up plans. There's the provider and the consumer and the ID, and then you've got a discount proof. And they check that they get the discount type, and they check if it's a code discount, or if the ERC discount, or if there's no discount, and it returns that. That's interesting. Okay, verify and consume discount, verify code discount. So these are just internal functions that get called. So yeah, this basically just sets up a whole bunch of plans, allows you to disable them, enable them. Yeah, so let's see what they do with the plans. I think that's our next step. Let's go subscriptions. Cool. So the interface has a subscription status and a manage command. So you can change a plan, cancel it, make it due date, renew it, clear, discount, pause. Okay, so there's commands you can do for the plan.
Got your data structure.
Subscriptions, plan info. What's the difference between a plan and a subscription?
I think you can have many subscriptions in one plan.
Okay. So a plan would be like a Netflix thing, and then people have many subscriptions.
Yeah, then you can have like monthly subscriptions, bi-monthly subscriptions.
Okay, yeah, because plan has a price, a period. If there's a free trial, okay, cool. Okay, so they've got you can create a subscription, you can create a network subscription. You can change your subscription, pause it, resume it, cancel it, get it. So there's a consumer subscription and a provider subscription. And then a whole bunch of events. Cool.
It's everything you could basically do on a normal subscription.
Yeah. This is like, yeah, so this is basically I want to see what's in their manager if this is their normal subscription thing. Cool, go for it. I'll let you take us through this contract, and then I'll just scroll down as you go.
Yes, please. So we've got a few mappings, consumer subscriptions. That seems to be a list of subscriptions to the consumer address. We've got a subscription ID to subscription struct. Okay, all different storage variables. Okay, could you scroll down a bit? Oh, another initializer. Seems everything's upgradable.
Yeah, which makes sense.
Oh, could you scroll up? I just want to see which NFT standard they use.
ERC 721.
Is it 721? I missed that.
Yeah, ERC 721.
Upgradable.
Yeah. I assume it's because they won't have to mint multiple at once. So there's because you just literally minted only one when you subscribe.
Yeah, I don't think someone could take out two of the same subscriptions. That doesn't make sense.
Exactly. So I don't think they really need to try and save on mass minting costs. Yeah, so that's clever that they do it that way, because it's obviously more expensive to transfer using ERC 721A, which is what they're going to be doing. So you don't want it more expensive, and then there's probably no need for 1155 here either, because although you could have multiple different types of subscriptions and multiple different IDs under that. So 40 types of a Netflix subscription, 40 types of that.
I suppose you could, but they seem to have structured it in a way that you make your 721 as composable as possible.
Yeah.
So you can just put in whichever parameters you want on your subscription, and it just mints that unique one.
Yeah, makes sense.
It's interesting though that they only use the NFT for their subscription model. I noticed the other models use they do a workload.
A workload?
Yeah, so they just encode all the data that needs to be processed.
Okay.
So I guess we'll dig into that a bit later, but I thought that was pretty interesting.
Yeah.
Scroll down a bit. Normal NFT things, token URI.
Standard before token transfer. There's the meat of it.
Yeah, there we go. Subscription methods. Create subscription. Takes in a nonce, takes in bytes 32 array of plan proof, discount proofs, cancel act. Okay, interesting. Takes in a provider signature and a CID.
Yeah, and then it calls an internal function. Let's go down to that.
Let's go check that.
Jeepers, it's a lot of if-else statements there. Sure. Big statement. Big function.
Was that it? Create subscription. There we go.
Cool. I'll go through this then. Yeah, so there's a provider, which is basically the person who owns the subscription. And they basically just verify the Merkle routes just to make sure everything's like correct, and they verify your plan proof. I'm sure that's here somewhere at the bottom. There'll be like, yeah, verify plan proof.
Yeah.
Which they call another function, but that's in the subscriptions plans that we looked at earlier. So they do that. They get the plan info, and they get a subscription ID for the subscription that we are creating. So they just generate an ID, which I assumed used like a Ketch algorithm. Let's say get subscription or generate subscription ID. Yeah, I just use a Ketch 256 and basically encodes an ID for the subscription, and it saves it in this variable subscription ID. We require that our max active is equal to 0, or that our current active subscription count for that plan is smaller than the max, so that we haven't hit our max number of subscriptions for that plan. And we have a get plan status, so we require that is enabled. So we can't create a subscription to a plan that isn't that's not enabled. The plan has to be enabled for you to have a subscription. Once that's done, then they mint. So they mint a subscription NFT, and with that ID to that sender, and then they create a subscription object.
Yeah.
Which, once again, I would have done this all in one line, but I guess what they're doing is also fine. And they're just then setting all of the subscription details in this here. So they're setting your plan data, network data, all of that stuff. All the ones that they can set now, they're setting. And then they just do a bunch of checks. For example, they check if the price is 0, then they make the subscription status active, and there's no renewal because it's free. If it's in a free trial, then the status is trialing, and they renew at the end of the free trial period. So there's a whole bunch of like information that they need to check just to set certain data, and then they update all of their arrays. So like the consumer subscriptions array, they push that ID. The provider subscriptions array for that provider, they push another subscription because now there's another subscription under that provider. The active subscription count they add. So yeah, they do all the mapping updates, which I don't know, I might have done before the mint itself. I don't know how you could recursively call this, but we'll see. Then they verify the discount proof, and the renew a subscription registers. Okay, so by renewing the subscription with the manager, it's basically registering in the manager contract. Cool. And then just check if the status is active or trialing. It has to be, otherwise it's not going to work. And then they submit an event, and they return the subscription ID so that whoever calls the function can just see their subscription. Cool. So then they have chain and plan, which calls an internal function. So we'll go down to that shortly. They have pause subscription, which basically just makes sure that they're not in any of these stages. And if they it is allowed to be paused, and then if it is allowed to be paused, we can set the status to pending pause. So just a whole bunch of checks. And also it's got a when not paused modifier. So that's should be up here. I wonder where that is. It's obviously in one of these.
I think it's in the pausable.
Yeah. Cool. Same with renewal. You can renew it only when it's not paused. So it checks that either the subscription is paused or pending a pause. But I wonder why would they check if it's paused?
No, that's resuming.
The plan must not be paused, not the subscription. So this when not paused is checking that the plan is not paused or is the contract not paused, one of the two.
Yes, that would make sense.
And then it just sets it to active because you've renewed it. Updates the plan info to active. Make sure that we haven't got a max amount of active subscriptions. If we haven't, then it's fine. And provider active subscription count. It updates all the mappings. Oh, sorry. Updates all the mappings and then sets a new renewal time, and it calls renew subscription in the manager. Cancel subscription will do the same thing. It just checks all of the information that we need, and then we cancel. So we make sure that the message sender is the owner of the subscription. Otherwise, you can't cancel a subscription that you don't own. And then it sets UN32 cancel at is obviously just a time when to cancel it. And yeah, then it just makes all the changes. Manage command. And then just a whole bunch of getters. So let's look at manage command. So these are just a whole bunch of if statements based on what the command is. If the command's renew, past due, all that stuff.
And that's from the enum that was in the
interface.
In the interface, yeah.
Cool. So you can basically call manage command with a specific command, and then it will do something for you.
Execute that. Yes, I like the way they've set this up.
Yeah, I actually quite like this as well. If you want to change your plan, then you get your data that you want to change, and you create a new plan ID with your new plan info. So your new plan info that comes in, you set the new ID to that, and then you set your data to pending plan data. Yeah, and then you delete the old one.
Yeah.
Out of pending. And yeah, you just set your minimum terms and a whole bunch of stuff. So you basically just change. You can cancel your plan, which burns your ID, your NFT, and it sets your status to cancelled, and then it updates all of your mappings. You can pause a plan, which will just update to paused, and update all of the mappings. You can say that it's due. So once again, you just update the status. You can renew it, which then just gets your plan info and make sure that it's in the trialing stage. And then it updates your renewal period. So it takes from now to the period that you can renew again in the next one. And then just changes your status to active. And the last thing is clear discount. And then you just set the discount ID and data to naught. So yeah, it's just a nice way of having different commands that do different functionalities.
Yeah, nice and elegant way of doing it instead of calling each one as a function individually.
Exactly. Cool. Let's look at the last part of subscriptions, which is the manager. And it just has a type, which is none, active, or past due. Queue position, size, and item, process a single payment, renew a subscription. Yeah. So we've got a whole bunch of subscription plans and subscriptions, which are just coming from the other two contracts, which we've been through. They've got a vault, which they obviously use for payments. There's a payment fee, or there's a rate for when discounts are applied. They've got this, which is used to reduce the payment fee based on the quantity of staked cask. So you obviously, if you stake, you get your payment fee is less because you're staking funds. And then the size of buckets to group the subscriptions into for processing. So that's just a way of them processing all this information. We won't go too deep into that, but they've got a queue of things that they need to process and their buckets.
Forgive my, maybe this is just my inexperience, but is bucket just a software development term for a collection of data?
Exactly. It's just how much data gets held in one kind of cluster, or software development call it bucket. It's actually, I wouldn't call it a software development term. It's a data structure term. A bucket is it's known in data structures as especially in queues as the bucket. So yeah, let's get into this. So there's a modifier and there's an initialize function because it's upgradable. They basically just set all their plans and stuff, and then they set parameter defaults on initialization. So minimum value, fee, rate, factor. They pass plan data, so you can send in plan data and it'll update all the information.
So it updates the way you were explaining on how you would update a struct. Is that you would do all in that? Yes.
Yes. So you'd say plan info and then open the brackets and then actually just do all the stuff in one.
I would think this would be a little bit cheaper than having to call it individually after you set the.
It's you keeping, so the way they're doing it is like, if you go like look, it's they create the object, but they keep it in storage. So if you had to create an object and keep it as a state variable and then call it, it would be super expensive. But I think because it's storage and it's local, it's not too bad. But I don't know which one's cheaper, but you're probably right. I think it would be this one. Yeah, so this is just basically, I'm keen to see how they process payment. So there's a consumer and a provider. So let's call it Netflix and myself. And I've got ID number 1 and the value is 1,000. Then it gets my subscription and it gets my payment fee rate. And it checks if I have a stake factor. So if I have staked, and if I have, it will figure out how much like the fee is going to be for the transaction. So it gets a payment fee rate adjusted, and then it gets my provider profile or Netflix's provider profile, and gets their payment address, and then it sends a payment from myself to their payment address with the value that we sent in and my payment fee rate adjusted. So we send that in, and then what it does is it works out your protocol fee, so how much they're going to take. It checks if it's a network data or just a normal consumer data. If it's a network data, it works out network fees and then does a protocol payment from the vault. If it's not network data, it just straight up does a protocol payment. So everything's coming from the vault where they keep all their funds. And then you can queue an item, queue size, a whole bunch of other stuff.
Yeah, that looks like just backend functions just to check your queue.
Perform upkeep, check upkeep. So just
that's a Chainlink keeper function.
Well, renew. This is the renew subscription that I went through. So I'm not going to go through the rest of this. I think it's pretty forward how they do it. I'm quite keen to go check out, because we're running out of time. Maybe should we check out P2P? Should we check out DCA, or should we check out the?
No, let's check out P2P. I'm keen to see P2P.
Okay, so So they have a manager, which obviously does all the functions. They store a map of the ID to the info. So let's go to the interface and see the P2P.
There we go.
So they've got a status
Yes.
and a command, so you can cancel, skip, or pause. And then they have a peer-to-peer struct, so that the user who you're going to send to, amount, total amount, current amount, number of payments, number of skips. Oh, so you can set like a subscription payment. So like it pays, I want to pay you 3,000, and then it pays you that over a certain amount of time. Which is very similar to what the protocol we looked at last week was.
But it seems this one's quite customizable in that you could say, I want to give it to you this month and not next month.
Yeah, you can skip payments. Yeah, so that's quite cool. So it's upgradable again. So we're not going to go through all this. Yeah, so you send in. So they get an ID once again by hashing it. And then they get a P2P, which is in storage again. And then they just set the user, who it's going to, the amount, the total amount, the period, and then when it was created and processed, and then the status, which would be active because you're creating it. And then they just add it to the array. So if you add it to the array before you do those setting of variables and then set it, that would be super expensive.
Yes.
Because then you're just calling a state variable over and over again, which for everyone who doesn't know, calling a state variable is a lot more expensive than calling a local or storage variable. So if you keep an object in memory or storage, it's a lot cheaper than trying to call an object from state. So then they register it through the plan manager, and then they make sure the status is upgradable and that number of payments equals 1. Make sure so just making sure that the first payment succeeded, which obviously happens on register, I would assume. You can pause it, which literally just update the status to paused, but also make sure it was active. You can't pause something that was already paused or cancelled. You can resume it, but you would have to make sure it was paused at the time. And then just to make sure that the manager knows it's resumed, you just register it again. You can cancel it, and you can get them. There's this command. If the command is skip, then
it skips for that period.
Yeah, I wonder.
Yeah, it says it'll process it it'll tell you when to process that payment, judging by the period that is in the data object.
Okay, based on the command. Okay, cool. Yeah, then you can pause it or cancel, and then process, manager processed, just basically saying that the amount's gone up and you've gone through a payment, and then there's just a random bunch of setters. So let's go look at the So once again, it initializes. So register calls a process work unit.
Yeah, and this is what I was talking about, as opposed to the subscription model.
Okay. So yeah, this basically what it's doing is so it gets the payment object and checks that the status is not active. If it's not active, then you return. Only if it's active can we process. So if it's active, we get the timestamp, and then we check if it's not time that we're supposed to process it, then we schedule it. So we add it to a queue. If it is time to process it, then we get the amount we need to process, and we do a bunch of checks, and then we do a transfer. So we call this function, which calls the Cask vault and does a protocol payment. If that successfully goes through, then we call manager processed. Process schedule.
Yeah, that just schedules the next one.
Okay. I wonder what calls the schedule, like what makes the schedule go ahead. Like how a schedule actually goes, because like in blockchain, it must be a front end trigger that checks the time or something, and
it's on the
up and have funds there for if anything needs to happen, and then they've got.
Yeah, it seems like you can use you could just keep stable coins in your Cask wallet, and they'll change it to link for you and pay you.
This vault came up quite a lot. Geez, we should actually have a second episode.
Yeah, there's
a lot of stuff going on this protocol. We go to the DCA. This was their last feature to show you. Basically, just purchases at a specific time, so you can create a DCA with your assets and the data you want to use for swapping. And you can pause it, resume it, cancel it, verify your asset, a whole bunch of stuff. You can skip, you can process. So he has the process function, like similar to in the peer-to-peer payments. You can register a DCA. You can process a DCA purchase. So there's a whole bunch of stuff you can do. I feel like we could have a whole nother episode on the DCAs, and
I think we could have one a DCA just by itself.
The DCA, yeah.
Yeah.
So yeah, that works pretty cool. Like I'm impressed with it, and like it seems like they're updating it all the time, and just like trying to make updates, and yeah, it's interesting, and a lot of people I think are trying to do this, so it will.
Yeah. I think this is it's one of the next steps in on the blockchain.
So now we just need something like people to create protocols on like Lens, like you create like Spotify or something on Lens, then you can use this for your payments. And then like next thing we know, we've got a whole Web3 integrated platform that has subscriptions, and the platform itself was built on Web3.
I like the P2P money transfers. I think I like those the most. Just purely because if we could integrate that into a mobile platform, I mean, anyone with a cell phone could send things to each other, and that's huge.
Yeah, just gas fees. That's the only issue.
Yeah, maybe we should dig into next time how they get the no gas fees.
Yeah, I think maybe they pay gas fees through your protocol fees.
That would make sense.
If they somehow reroute the gas fees, I'm not sure. But that could definitely be an option. Otherwise,
I also like that they allow you to stake your Cask tokens for
but I don't know,
even more discount.
Where?
I didn't see a staking function.
No, I also didn't. Maybe it wasn't in the vault. No.
Oh, I think I saw on the docs that staking's coming soon. I don't think that's implemented yet.
Because the treasury's like their fund management is very basic. Is this not time lock controller? Here we go. Time lock controller. When set as the owner of ownable smart contract, enforces a time lock on all only owner maintenance. Okay, that's not it.
No, I'm sure I saw that it was in progress and still being developed.
Hectic. Sweet. Well, yeah, that is Cask. Very new. They're really doing some cool stuff on Web3 and trying to update the world and get kind of something that we haven't seen dug into too much in Web3 get deployed. And we learn, we do stuff, we make mistakes, and it's cool to just go through a system like this, something completely different. And hopefully we'll all be using a system that does streaming and subscription management and peer-to-peer and automatic bars and all those things as soon as possible. So yeah, thanks for joining us, Myles. That was awesome to have you on your first Solidity Fridays. I'm sure we'll have you back soon.
Oh man, thanks for having me. I look forward to coming back.
Yeah, and then maybe we can do an episode 2 on the DAs sometime soon.
Oh yeah.
But yeah, from the Solidity Friday side, that's for this year, and we will catch you all next year. Come back with some cool questions, and great. We'll see you then. Cheers.
Bye.